Hi everyone, this is Nilab Muhammad Rafi. In this video, we're going to talk about molecular formula and empirical formula, which is covered on the second week of our course website. First, we need to know what is a molecular formula. So molecular formula shows how many atoms of each element are in a compound. For example, this molecular formula shows that in the compound we have 4 carbons and 8 hydrogens. The empirical formula shows the ratio of different atoms in a compound. For example, in this formula, we have C4H8, and the ratio between carbon and hydrogen is 1 to 2. Therefore, the empirical formula will be CH2, which means that for each carbon, we have 2 hydrogens. So let's say we are given a molecular formula and we are asked to find its empirical formula. Here we have C5H10O5. So for finding the empirical formula, we need to find the largest number that all these numbers can be divided by. The largest number here is 5. 5 divided by 5 gives us 1. 10 divided by 5 gives us 2, and then 5 divided by 5 gives us 1. So this is the empirical formula of this molecular formula. We do the same thing for the second example, C2H12O2. We divide all these 3 numbers by 2 to find its empirical formula, which gives us CH6O. Let's say if the ratio of the atoms in the molecular formula cannot be further simplified, in this case, the molecular formula and empirical formula will be the same. For example, here, molecular formula is CH2. Since we cannot simplify this any further, so the empirical formula will be the same as its molecular formula. Same thing for the second example, C5H12, and C5H12 will be the molecular and empirical formula of a compound. Each molecular formula has only one empirical formula, but each empirical formula has many molecular formulas. Do you agree or disagree with this statement? Discuss your reasons for doing so. So let's see here. We have 4 molecular formulas here. We need to find if these 4 molecular formulas have one empirical formula. For the first one, we have C4H8. For each carbons, we have 2 hydrogen. So this can be the empirical formula for the first one. For the second one, we have C3H6. So for each carbon atom, we have 2 hydrogen atoms. So which is the same empirical formula here. Same thing for the third one, C5H10 has the same empirical formula, and also for the fourth one has the same empirical formula, CH2, which means that for each carbon atom we have 2 hydrogen atoms. So in this case, we can say that one empirical formula can have multiple molecular formula, but one molecular formula can only have one empirical formula. First reason is empirical formula is the simplest ratio of all atoms present in a compound. So ratio of atoms in different molecule can be the same. For example, here we have 2 compounds here. The ratio between these 2 compounds in their atoms are the same, which means that for each carbon we have 2 hydrogens, and here the same for each carbon we have 2 hydrogens. So the empirical formula for these 2 will be CH2. The second reason is that molecular formula shows a fixed number of different elements in a compound. In molecular formula, if we change a number of particular element, the molecular formula will change. For example, here we have methane, which is CH4. If we change the number of hydrogen here, it will give us a different molecule, which is CH3. So these 2 molecules will not be the same. So therefore, we can conclude that each empirical formula can have different molecular formulas, but each molecular formula has only one empirical formula. Thank you for watching.